All right, so let's go ahead and solve this differential equation. So first things first, as always, I think I like to rewrite this notation as dy by dx equals, so minus e to the x plus y equals 0. This is just the same thing, okay? And now I'm just gonna, so my approach usually is to try and get the y, so get the two terms on two different sides, right? So get dy on one side and dx on the other side, and similarly get the x and y terms respectively next to those dy dx terms, right? So first thing I'm going to do, like, just multiply this out by dx. That gives us dy minus e to the x plus y dx equals 0. Okay, so now the question is, how do we separate these two out? Um, and what's important to recall here is a rule of exponents where, so if you have an exponent, let's say a to the b plus c, that can be written as a to the b times a to the c. Okay, so I mean, for example, if you just had, if for example, 2 squared times 2 squared, this is the same as 2 to the 4, right? So that's the logic behind that. Um, okay, so now what we're going to do is I'm just going to do the same thing here. So I'm just going to say dy, oops, dy minus e to the x, e to the y, dx equals 0. Remember, e is just a number, right? So the same principle applies. Now I can move this, bring this whole entire thing to the right side. So that just gives me dy equals e to the x, e to the y, dx. Okay, now we're getting closer to something we can try to integrate. Now we can just bring this e to the y to the left hand side. That just gives us 1 over, well, we do that by multiplying it by 1 over e to the y. So we have 1 over e to the y equals e to the x, oops, 1 over e to the y dy equals e to the x dx. Okay, so now that we have that, now we can try to, now we have all the dy's and the y's on one side and the ex and the x's and dx's on one side. We can try and integrate these together. Okay, so let's just take the integral of both sides. Okay, so that gives us, so this is just, now we're gonna have to do some integration trickery here, but this is quite straightforward. This is just going to be, it's gonna be a different color. So this is just gonna be e to the x plus c, right? The integral of e to the x is just e to the x, right? So here, so for this part, so for this, we're gonna have to do some, let's do some, we're gonna do some algebraic manipulation and then integrate, okay? So let's just say, so this is the same as the integral of e to the minus y dy, okay? So now we can recognize that you can use integration by substitution, okay? Because so if, let's say, if we let's just say let u equals minus y, then du equals minus 1 dy, right? So this is great because we have so, well, okay, so we're just going to do, so minus minus du equals dy. Okay, great. So we have a dy over here. Okay, and we have minus y, so we can go ahead and substitute this. This is the same as saying the integral of e to the u minus, rather, multiplied by minus du, and we can bring this bring this negative sign outside, and that's just the integral of e to the u. So it's just minus times the integral of e to the u, which is just e to the u, right? Okay, then we can substitute this, so plus c, and now we can substitute this u back in, which is, this is equal to minus e to the minus y e to the minus y plus c. Okay, great. So now we have, we've got this integral, so we can just bring these two together, right? So we can bring these two solutions together. We get minus e to the minus y plus c equals e to the x plus c. Okay, and now we're gonna record this as just one c. So because this is just the sum of two arbitrary constants, right? Sorry about the ambulances noises. I've had 3 ambulances in a row. Okay, so this is just going to be minus e to the minus y equals e to the x plus c. Okay, now when you look at this y on its own, so this is, so if you just, so let's just multiply this whole thing out by a negative sign. So we get minus e to the y equals minus e to the x plus c. Remember, this is an arbitrary constant, so it doesn't matter if it's plus c or minus c, it's just plus an arbitrary constant. Okay, now we can just take the log of both sides. That would give us minus y equals the log of minus e to the x plus c, and y equals minus the log of minus e to the x plus c. And that's the answer.